Third time's the charm for Starship 38's static fire at Starbase. Can we still see a launch in September? Starship is going to Florida by ship. An armada of test tanks emerges. How long before we see real Block 3 flight prototypes? NASA brings Viper back from the dead, optimizes rockets with pressure-sensitive paint, and integrates one more vital part for Artemis II. We are going to the moon. My name is Felix, welcome to What About It, let's dive right in. Starship updates. SpaceX has once again spoiled us with a static fire, even after 2 aborts. After 2 scrubbed attempts, SpaceX finally lit the engines on Ship 38, but what happened in these 2 attempts? The first attempt was tracked down to possibly being a GSE or ground support equipment issue. The ground what? In short, the tank farm. During the test on the 18th, the tank farm began to spool up, or did it? For the most part. The commodity side of Pad 1 has 3 main parts. We have the tanks. They are the easiest to spot and a landmark at Starbase. The pumps are what drive pressure and move things from one spot to another. The subcoolers are there to keep things very frosty. For the sake of this explanation, we'll be looking at those, specifically how we can tell that they are running. After starting up, the liquid oxygen subcoolers vent out of pipes leading to the grass, also known as the famous grass vents. Although it looks like fun, we at Y do not recommend you try to touch this. And these worked as intended during the test. Moving to the liquid methane subcoolers, stuff was not so normal. They started up as they should, but then we got into fuel load, kind of. The big vents from these subcoolers during a launch are what we call the V vents, because it looks like a V. What this indicates is that liquid methane is actively flowing through the subcoolers and to the vehicle being tested. The liquid methane subcoolers are located right here. And do you see what we're missing? The methane subcooler vents. No V. What this tells us is that liquid methane was never actually flowing to the vehicle on this first attempt, which is likely why a scrub was required. The second attempt was also innovatively scrubbed. Unfortunately, this one is a little harder to track back to its cause. The tank farm spooled up as usual and everything was going well into prop load. See the methane subcooler vents? Both a liquid oxygen and a liquid methane frost line appeared for a short amount of time before being detanked. SpaceX has likely tracked the issue down by now. After the 2 attempts we just went over, SpaceX went into the 3rd attempt with a fresh mind. Just as with every test before, the road closed and the tank farm began to spool up. The OLM vent started, indicating that the lines were once again being chilled in preparation for propellant load. A little while later, the vent cut off, meaning liquid oxygen loading was now underway. After cruising past the single-engine static fire load point, it was clear SpaceX would be going for a 6-engine static fire. With the propellant load finished, Ship 38 was ready to show what it could do. And just like that, SpaceX ignited 6 of 6 Raptor engines, blasting downward with a force very likely passing 1,000 tons of thrust. What a beautiful sight to see following the 2 aborted attempts. This is a standard static fire, as it tests all 6 of the Raptor engines aboard the ship used during the staging and ascent phase. But this does bring us to the question of why SpaceX skipped the previous single-engine static fire. Maybe it just isn't needed now. Now here comes something I never thought I'd see done. SpaceX is finally going to transport a Starship horizontally. Back on September 7th, Elon Musk posted something mysterious on X. "You'll thank me later." For what, Elon? For what? Was this just another random Elon post? Was he trolling? Was SpaceX making another rocket? While all of these are good guesses, it was something completely different. Just 7 days ago on the 16th, Elon Musk posted again that this would actually be a water ship to transport spaceship from Starbase to Cape Canaveral. A water ship to what? SpaceX has a long tradition in maritime operations, even though it serves the space industry. Thanks to them, boats are increasingly associated with rockets. First, less successful, and then this happened. April 8th, 2016. Yeah, it's been almost 10 years now since this happened. Since then, the space industry was never the same again. Did you know that SpaceX operates 20 to 25 different ships? Dragon recovery ships, fairing recovery ships, support vessels, and 4 autonomous drone ships for landings. Before SpaceX, rockets and boats didn't happen together much besides transportation from a factory to a pad. And that's exactly what SpaceX is going to do now as well, just slightly bigger. That's right, SpaceX is bringing another barge into operations, and this time not for landings. This time it's to transport starships to the Cape Canaveral coast from Starbase. Ships and boosters. Although this is not new knowledge, it is now officially confirmed by SpaceX. When the Space Launch Complex 37 Environmental Impact Statement was released on page 47, Table 2-1, in the section Transportation of Launch Vehicle Components, it states that Starship Super Heavy and components would arrive from SpaceX's Starbase in Texas. The components would be transported horizontally via a barge from the port of Brownsville, Texas to CCSFS Port Canaveral. All this really says is that Starship will be transported horizontally. That checks out. What people don't know is that SpaceX already has parts for this. And what you also don't know is this nifty tool. Flight 10 was an exciting success and we enjoyed every minute of watching it with you. But like all SpaceX news, public opinion largely depends on what the news say. One of the best tools to see what the broader media world is saying, and my top source for my own research for What About It, is ground news. So let's see what we can find when researching. One headline neutrally states SpaceX's Starship completes successful mission during 10th test flight. Another outlet focuses on sensationalism, saying part of Starship explodes during SpaceX's latest test flight. There's always more than one side to a story. Go to ground.news/y for the full picture. I can't think of a better platform to help me make sense of it all than ground news. Founded by a former NASA engineer, my partners built the only app and website that shows how the world's media cover the same event for a more comprehensive understanding of any issue. Simple, ad-free, subscriber-funded, and built for informed discussion. Perfectly aligns with our mission at Y. Ground News offers a browser extension to flag biases and link to science-focused sources. I've arranged 40% of their unlimited Vantage plan, just $5 a month at ground.news/y or by scanning this QR code. Become a part of our mission to help the world understand where space, science, and society are heading. Alright, back to the tool SpaceX already has for Starship shipping. More specifically, a possible breakover. A breakover is used to transfer a vehicle from vertical to horizontal. But Felix, can Starship support itself on its side? Excellent question. Starship is engineered with 3.97mm thin stainless steel. That is thinner than an eggshell in comparison. But SpaceX lines the inside of the tanks with structural stringers to strengthen them. These stringers are what allow a booster or ship to be transported without collapsing. The tanks can also be pressurized for a trip, making them even more structurally stable if needed. With the absurd amount of stringers inside these tanks, it allows them to be turned on their side and still stay structurally stable during horizontal transport. But another question we have is whether SpaceX will cover the vehicle during the transport. In short, we don't know. Super Heavy and Starship are already exposed to the harsh Gulf Coast air, and not much harm has been caused. On the other hand, SpaceX does cover its first and second stages when they get transferred from McGregor and Hawthorne to the Cape for Falcon 9 launches via truck. Although we cannot be certain, it does sound logical. It is easy to wrap a tarp around it after all. As for the route SpaceX will take, it is a solvable problem. There already is a shipping route all the way from Starbase to the so-called Turn Basin next to NASA's famous Vehicle Assembly Building at the heart of Kennedy Space Center. It's been used for decades. Currently, for example, it is heavily used to ship SLS parts like core stages and other components for Artemis launches to the Kennedy Space Center every now and then. To sum all of this up, a water transport to the Cape is a necessity for the program, both to transport new vehicles to and from the Cape and to transfer flown vehicles for another mission. Before we move on to the new generation of boosters, hit the subscribe button to stay informed. Like this video if it brought you value and become a Y supporter for extra content. Up to 7 picture galleries per week, satellite, helicopter and ground photos and 3D animations. Chat with me and gain more insights on the topic you love. Thank you very much. Also check out raptor-roost.com for launch viewing tickets. Flight 11 is around the corner and there is simply no better spot to watch from. Now here's another very exciting topic. The new generation of boosters has also seen some new things. Version 3 is coming. On the 16th, SpaceX rolled a very odd tank out of the Star Factory. After being moved onto Highway 4, it took a short trip around the back of Mega Bay 1 and eventually into the bay. For now, we cannot go into details on this tank since we're still figuring it out, but you can expect more information in the next few episodes. But for things we know a little more about, SpaceX rolled out Booster 18's aft barrel section just after midnight on the 19th. And what this aft section shows is far more than you may think. This thing is a treasure trove of information. First, we have a series of pipes along the bottom of the barrel with 40 radial spaced boxes. Yeah, 40. We don't know why there are 40 of them, but 33 must relate to each engine, while 7 others are dedicated to other commodities. Then we have the bottom of the chines. 3 of the 4 are visible from this angle, but rest assured there is another. These are a redesign from the current generation of boosters, where the chines are located 27 degrees and 126 degrees from the plus Z axis, whereas on this new generation they are 38 degrees and 140 degrees from it. For better understanding, plus Z is where the quick disconnect is located on the current Super Heavy version 2. It's the leeward side of the rocket. Following this, we have both of the autogenous pressurization pipes. One liquid methane autogenous pressurization pipe and one liquid oxygen autogenous pressurization pipe. These are used to keep the tanks at flight pressure with gas produced by the Raptor engines while they are sucking the tanks empty at the same time. Take a little, give a little. Next to the methane pipe, we can see one of the 2 quick disconnect plates used for these boosters. Yeah, this new generation of boosters has 2 quick disconnects. This is the LOX-QD as indicated by it lining up with the LOX-QD for Pad 2. Last but certainly not least, we have the transfer tube connection point. That is the tube connecting the upper tank to the engines running straight through the lower tank. This is the final part that the transfer tube connects to in the aft, and it also serves as a distribution manifold for liquid methane. Without this, the booster wouldn't work. Now you're a version 3 booster expert. Booster 18's liquid oxygen tank stacking is now fully complete, and SpaceX can start stacking the liquid methane tank. It is incredible to see this evolve in real time. We should see a significant reduction in the stacking time for Booster 19. That is, after Booster 18 is complete. Starship has come a long way. Here's SN1 for comparison. This was filmed by Mary for NSF on February 28th, 2020. And now we're looking at the first version 3 booster being assembled with 10 Starship launches done already. Time is flying when excitement is guaranteed. Do you want to see mind-boggling stuff from the air with your own eyes? Go to redlineheli.com/Felix. $25 off for anyone using the link. The Redline Helicopter team is waiting for you. They'll show you the same Starbase views our photographer gets on his Starbase flights. Unforgettable stuff. Northrop Grumman has successfully avoided a disaster. The Cygnus XL, Northrop Grumman's latest cargo spacecraft, successfully completed its inaugural mission to the International Space Station. Its arrival was delayed by 1 day due to some significant thruster problems, though. These problems appeared when the mission-critical orbit raising burns were initiated. Those are needed for the spacecraft to arrive at the ISS after separation from the rocket's second stage. Issues with the main engine forced Mission Control to come up with alternative flight plan options. It turned out that during 2 crucial delta velocity burns designed to raise the spacecraft's orbit toward the ISS, the software triggered a safeguard mode. This early warning system shutdown caused a premature engine shutdown on 2 separate burns, namely burns 3 and 5. While the technical analysis was ongoing, the Cygnus XL, named SS William Willie C. McCool in honor of the pilot of the disastrous Space Shuttle Columbia mission STS-107, had to be parked in a safe position. In this case, the spacecraft was kept at a position behind the station while analyzing the anomaly. You can absolutely not compromise on safety when it comes to space stations. Mission controllers ultimately determined that the thruster hardware operated correctly. It all came down to overly conservative software settings rather than mechanical failure. A new burn sequence was developed and the craft was successfully guided toward the ISS. The ISS robotic Canadarm captured the Cygnus XL on September 18th, one day later than initially planned. With its payload capacity increased by 33%, the spacecraft is able to deliver around 5 metric tons to the space station. While this is still slightly lower than SpaceX's Cargo Dragon 2, which can deliver 6 metric tons in one go, it is a significant step forward for Northrop Grumman and Cygnus. From the aging ISS, let's turn our attention toward the future. The moon is waiting. With the Artemis II mission slated to launch in the first half of 2026, NASA's Kennedy Space Center teams have achieved another milestone. The Orion spacecraft was integrated with its launch abort system on September 17th. This almost 14-meter tall structure is designed to swiftly carry the 4-person crew inside Orion to safety in the unlikely event of an emergency during launch or ascent atop the Space Launch System, or SLS. This abort system might seem quite simple to the untrained eye, but in reality it is quite sophisticated. 3 solid rocket motors are each performing a dedicated task: jettison, attitude, and abort. In an emergency scenario, the abort motor would pull the crew module away from the launch vehicle, while the attitude control motor steers and orients the capsule for safe separation. Finally, the jettison motor separates the abort system from the crew module before parachute deployment. If needed, the emergency system will activate within milliseconds. During a normal launch, Orion will shed the abort system and leave it behind once the crew is safely through the most dynamic part of ascent. The reason is straightforward. It leaves Orion thousands of pounds lighter for the rest of its journey. Over the next few weeks, teams will complete the remaining closeout activities before moving the spacecraft to its final stop before the launch pad, the agency's iconic vehicle assembly building. Once it has arrived there, Orion will be stacked atop the massive SLS rocket, bringing NASA one step closer to returning humans to lunar orbit for the first time in over 50 years. Yes please, I can't wait, go NASA! I stood at the VAB when Artemis I launched, and I'll never forget it. Onward to Artemis II. It should not come as a surprise that NASA engineers are leveraging cutting-edge technology to solve critical challenges for the Artemis II mission. To optimize SLS's performance, a combination of supercomputing power and advanced wind tunnel testing is an invaluable tool. Higher than expected vibrations caused by unsteady airflow near the solid rocket booster attach points were observed on SLS during Artemis I. I didn't see anything. To address this issue for Artemis II, engineers suggested incorporating 4 strakes. These thin, fin-like structures are designed to enhance airflow stability and reduce component vibration. The way they came up with this solution is remarkable, and it involved unsteady, pressure-sensitive paint. I never thought about the sensitivity of paint in my life. What's that all about? When applied to scale rocket models, this specialized paint allows for the measurement of aerodynamic pressure changes over time. And how does it do that? High-speed cameras record variations in the paint's brightness, which correspond to pressure fluctuations, offering remarkably detailed insights into the rocket's aerodynamic surroundings. So the paint flickers under pressure, and that's what they measure. This revolutionary approach leverages a high-speed network to stream wind tunnel data directly to NASA's Advanced Supercomputing Facility. There, the Cabeus supercomputer, NASA's largest GPU-based computing cluster with 350 NVIDIA superchip nodes, processes the information. Do they have a Gorn superchip? Results are then displayed on a hyperwall visualization system, drastically cutting analysis time from weeks to mere hours. Definitely a Gorn superchip. This collaborative effort produced complex computational fluid dynamic simulations that explained the physics behind the strake solution and filled gaps where physical sensors couldn't reach. And they also look absolutely stunning. Boeing teams are currently installing the strakes at Kennedy Space Center, targeting October 2025 for completion. And a previously shelved NASA mission has now experienced an unexpected resurrection. Viper is literally back from the dead after a tumultuous journey over the past years. Originally designed as a key piece of NASA's Artemis program, the car-sized rover was fully assembled but cancelled in July 2024 due to cost overruns and schedule delays. The decision turned many heads as NASA had already spent roughly $450 million on the mission before pulling the plug to save an additional $84 million. That makes no sense. NASA initially planned to dismantle the rover and repurpose its instruments for other missions, but also looked into options for the lunar delivery of Viper. Now, the agency selected Blue Origin to deliver the wheeled robot to the lunar surface in late 2027. NASA awarded Blue Origin a $190 million task order under the Commercial Lunar Payload Services program. The company will use its Blue Moon Mark I lander to deliver on its contract. The lander is set to perform its first lunar delivery mission later this year. This is one of the highlights we might still see in 2025. What do you think? Will Blue Origin be able to deliver its first Blue Moon lander to the moon in 2025? Let me know in the comments. Viper's scientific mission remains unchanged and critically important. The rover, whose name spells out to Volatiles Investigating Polar Exploration Rover, will search for volatile resources such as ice on the lunar surface and collect science data to support future exploration on the moon and Mars. The ice Viper is expected to discover could be converted into drinking water, breathable oxygen, and hydrogen for rocket fuel, all of which are essential resources for sustaining long-term human presence on the moon. Operating for 100 Earth days, the rover will venture into permanently shadowed regions near the moon's south pole. These are known to be some of the coldest spots in the solar system. Eternal darkness surrounds them. Ice reserves deposited in these regions have endured for billions of years. These are ancient resources that are ready for the taking. I can't wait until an astronaut sips some ancient eternal darkness water on the moon. That's it for today. Smash that like button, subscribe for more. This is what fuels the algorithm, and this is how you can help us for free. And if you want to learn more about how SpaceX's Raptor 3 engine works, watch this video next to continue your journey. Thank you very much for watching, and I'll see you again in the next episode. Maybe it just isn't needed. Pressure-sensitive paint. I don't know. The big vents.